Hello everyone, I'm by the name Martin Davize. I'm doing my bachelor's degree here at Ines Ruhengeri in biomedical laboratory sciences. Yeah, we are going to share together about simple questions and I'll be right there to explain clearly. So the first question is what are the risks of CART cells therapy? In simple words, CART cells therapy is a chimeric antigen receptor T cells therapy, which is the way of to get immune cells that correct T cells, and there are types of those T cells are types of white blood cells which are there to fight against a cancer by changing them in lab so they can find and destroy cancer cells. CAR T cells is also sometimes talked about a type of cells-based gene therapy. There is so-called a cell-based gene therapy because it involves altering of genes inside T cells by helping them to attack cancer. Uh, the question you may ask yourself is that how CAR T cells therapy work? It works in only different ways. It works normally in immune receptors and foreign antigens. The immune system recognizes foreign substances in the body by finding protein-coded antigens on the surface of those cells. Means the relationship between antigen and the immune receptors that so called key and lag. You remember that key and lag hypothesis, whereas antigen is a key and immune receptors are lock. Hence, the main key requires the specific antigen requires specific immune receptors. Meaning, a specific key requires a specific lock. Cancer cells also have antigen, but if your immune system do not have receptor, they can't attach to the antigen and help cell destroy cancer. As I have said above, the specific lock means just need a specific key. As I have said, when I put in this content, the cancer's antigen will require the immune which is specific to that antigens. So if I'm continue, there are some possible CRT size therapy side effects. Chimeric antigen receptor T cells therapy can be very effective against some types of hard to treat cancers, but it can also sometimes cause a serious life threatening side effect. Because of this, it need to give a medical center that is specifically trained in its use. Some side effect that I can cite is like cytokine release syndrome. This syndrome is comes from the release of large amount of chemical that are called cytokines into the blood. Those chemicals are cytokines. As you know, cytokines are those chemical messengers of immune system. So the way it work here, it comes and if it is released in a large amount, it can cause the lamp chart, the lamp up of the immune system which can lead to those serious effects, including high fever and chilling, trouble breathing, as these cytokine released large amount in the blood. They will attack the breathing organs that will lead to the trouble breathing, severe nausea, vomiting, diarrhea, headaches, fast heart beating, and sometimes you are feeling very tired. The risk factors associated with chimeric antigen receptor T cells. If I can mention, I can say that there is nervous system problems. The risk factors which is highly important is nervous system problems, which is associated by the condition as known as immune effector cell associated neurotoxicity syndrome. This which is a result in symptoms like headaches, change in consciousness, confusion or agitation, and also seizures. These also can be risk factors as it was in side effect, but it can also be in risk factors. The cytokine release syndrome, as chimeric antigen receptor T cells multiply, they can release large amount of chemicals which are called cytokines into the blood, which are ramp up the immune system. The seriousness of increasing of cytokines can lead to another risk factors or serious side effects such as allergic reaction during the infusion, abnormal of minerals in the blood such as potassium, sodium, and phosphorus levels. This is also known as electrolyte imbalance. An electrolyte imbalance is can be also caused by the cytokines or the release of high or large amount of these cytokines, which are chemical messengers of immune system. They can lead to weakened immune system with an increased risk of serious infections, as those white blood cells are reducing so that they can cause increase the risk of serious infections and increase the risk of getting another type of cancer. If you are getting CR therapy as conclusion, it is very important to report any side effect to your healthcare team right away, as they are often medicine that can help to treat them. How immune system or immunotherapy used to treat autoimmune disease? That is the 12th question. First, you have to ask yourself what is autoimmune disease? Autoimmune disease, when you say autoimmune disease, it means that the immune system goes awry and start to be attacked by another disease by attacking the body's health tissues. Immunotherapy drugs such as immune checkpoint inhibitors release the brake on the immune system and allow an immune cell to detect and attack tumor cells. In recent years, the use of immunotherapy for patients with cancer has been expanding rapidly. Immune checkpoint inhibitors, for example, has been tested in a growing number of cancer types. How does immunotherapy treatment work? Normally, as take home message, I can tell you that is treatment that uses certain part of person's immune system to fight against such cancer. This can be done couple of two ways. In the way of how it does or immunotherapy how it does by stimulating, boosting the natural defense of your immune system so it work harder to smarter to find and attack the immune. The treatment of autoimmune disorders. Treatment for autoimmune disorders, there are those anti-inflammatory drugs, corticosteroids, painkiller medications, immunosuppressant drugs, and physical therapies. The importance of those drugs or treatments for, if I can say, anti-inflammatory drug is there to reduce inflammation and pain, whereas corticosteroids is there to reduce inflammation. Killers such as paracetamol and steroid is going to kill or to reduce the pain, whereas immunosuppressant drugs is there to inhibit the activities of immune system, and the physical therapies they are here to encourage mobility. Question number 13. The question number 13 is said, how do T cells support B cells activations? Wow. Here everyone can ask him or herself how T cells support B cells activation. Remember that B cells obtain a help from helper T cells by acting as antigen-presenting cells for activations. The process which is called T cell dependent B cell activation. B cell use antigens complex to activate T cells and stimulate cytokines released from helper or CD T cells. The cytokine serve as co-stimulator or co-stimulatory molecule for B cell proliferation and differentiations. The presence of helper T cells in immune response increase the overall quality and effectiveness of the inflammatory attack. Hence, T cells promote the development of antibodies by providing high affinity, specificity, etc. Here the cytokines is there to stimulate and to regulate the cell activation and differentiation. The cytokines serve as stimulatory as I saw above and help in undergo proliferation and the differentiations. Oh, T cell independent B cell activation. Some antigen can stimulate B cells to proliferate and differentiate without the helper T cells. These T cells dependent antigen are microbial polysaccharide found on surface of pathogen cell wall. Therefore, multi-point binding to B cell antigen receptor can generate strong fast signal to activate B cells. One you want to take home as message is that when T cells bind on B cells antigen receptor can generate strong fast signal to activate B cell directly without co-stimulations. Those cytokines which are there to co-stimulate or in stimulation, they are no longer needed because T cells was there to bind on the surface of pathogen cells by their polysaccharide antigen microbial. Plasma cells that are activated in the manner secret antibody related to the TI antigen. So, because they do not activate helper T cells, they fail to induce B cells memory, class switching, or affinity maturation. Therefore, they tend to have lower binding affinity but higher avidity and limited antibody diversity when compared to antibody from DT B cell activations. Number 14 question. What is isotope switching and how is it regulated? Isotope switching, when you say isotope switching, is the shift of B cell from the secretion of the antibody of the isotope to different isotope. The characteristic features of the humoral immunity response is switch from AGL to other IgI isotope that typically occur subsequently to their first exposure to DNA. This switching or isotope switching is controlled by rearrangement that recombine variable region of gene. Isotopic switching is controlled by T lymphocyte-derived cytokines. The point as take-home message is this one. You have to know that it requires DNA rearrangement that recombines variable region genes, and it is controlled by lymphocyte delivery cytokines such as interleukins, gamma interferons, and GTG beta, which is direct B lymphocyte to switch to specific Ig classes. For example, ERR for direct neurin B cells to produce Ig1 and IgE, and human B cells to produce IgE and Ig4. For murine B cells, that second signal may also be provided by IL-5. Isotope switching in lymphocyte may provide useful model for directed DNA recombination in higher eukaryotes. This DNA recombination is required for only those higher eukaryotic organisms. Number last questions. What are the follicular T helper cells and why do they important? So, follicular T cells are those specialized cells that provide T cell helper to B cells and are essential for germinal center formation as it's their important affinity maturation and development of most high affinity antibodies and memory B cells. The importance of follicular T helper cells is there to maturate affinity and develop the affinity antibodies and memory B cells as they important. So the transcription factor in CD4 positive T cell of T helper follicular cell differentiation and development of germinal centers. Here there's a link which can we use to find more information about follicular T helper cells. The importance of them, as I have mentioned, is formation of germinal center and affinity maturations. As I continue, the field of this learning has now exploded with activity examining everything from biochemistry of transcription, molecular biology, and function, and discuss the most recent advances in these areas as well as complexities of T helper cell follicle cells. In addition, a new conceptual model is introduced to explain the relationship between T follicular cells and other CD4 positive T cells differentiation program. For oral presentation of review, see the experimental video one. If you search on YouTube or another searching materials, you can search like experimental videos to have a huge difference and relationship between T helper cell follicle cells and other CD4 positive T cells differentiation. Lastly, thank you for your kind attentions and your time we have been spending together and coming again next times. Thank you. Bye bye. Like, share, and comment to this channel is required. Thank you so much, awesome followers, students.